Hello everyone, today we are going to talk about what is vector embedding. So first and foremost, what is a vector? A vector is a mathematical object which has both magnitude and direction. For example, force. Force has a both direction and magnitude. But pressure, which is the force per unit area, is a quantity with only magnitude which doesn't have any direction. Similarly, different physical quantities can be represented with a vector. So in mathematical term, vector represented as a set of numbers in a space. For example, if you consider 2D space, we represent it with two numbers. One represents x coordinate, another represents y coordinate. Similarly, in 3D space, we use three numbers, each representing its coordinate axis, x, y, z. So why vectors matter? So vector matters because it is used to represent data in a very structured and efficient manner. It is very useful in machine learning and AI field for encoding different data like text, images, and other different types of structured and unstructured data because the machines cannot understand data in raw format like raw text or raw image. We need to convert them into numbers. So this data set can be efficiently represented and stored or encoded inside a computer using vectors. That is why vector is very useful in machine learning and AI. Then coming to the properties. So a vector has mainly two properties. One is magnitude, another is direction. And we can do different kind of operation like addition, subtraction, scaling, and dot products. So vectors are nothing but a way to represent data points in space. What is vector similarity? So vector similarity measures how close two vectors are in a vector space, indicating the relationship or closeness between the two vectors. So to measure similarity between two vectors, we use different kinds of metrics. One of the most commonly used metric is cosine similarity. So if the angle between two vectors is small, that means the vectors are more similar. If the angle between them is very large, that means they are not that similar. So to represent that, we take the cosine between the angle between two vectors, and that is used as a similarity measure. So that is represented as cosine similarity, or and which can be calculated using the formula cos theta equal to a dot b divided by magnitude of a into magnitude of b. So a dot b represents the dot product, which is nothing but the multiplication of the two vectors uh, coordinates. Like if one vector is represented at x1, y1, z1, another vector is represented as x2, y2, and z2, then dot product will be nothing but the multiplication of the numbers and summing them up, like x1, x2 plus y1, y2 plus z1, z2. So like this, we can calculate the dot product, and if we divide it by the magnitude of the two vectors, then we will get the cosine between the angles. So this is a way to represent the similarity between two vector. So we can also measure the distance or Euclidean distance between the two vectors to be as a measure of similarity between the two vectors. So for in case of Euclidean distance, this formula is used. So it is nothing but the squared sum of the difference between the code different coordinate values. So x2 minus x1 whole square plus y2 minus y1 whole square. If we have z coordinate, z it will be added here plus z2 minus z1 whole square. So like that, for uh, as the number of dimension increase, the formula will be further enhanced here. So these are the few concepts which is very useful in measuring the vector similarity. So now why it matters? So it matters because vector similarity used in different tasks like semantic search, clustering algorithms, or recommendation algorithms in machine learning. So it basically enables comparisons of different data points to find patterns and relationship among them. So what are now embeddings in case of NLP or natural language processing? So embeddings are nothing but vector representation of words and different kinds of data. The images also can be represented using embeddings. But in case of NLP, generally we refer to embeddings as the text embeddings. So it is a way to represent text in a numerical format using vectors. Here you can see the dog word is being represented by a certain set of number, and puppy is represented a certain set of number, cat and houses, these different words are represented as certain case of numbers. So usually what happens is that when we calculate the embeddings using neural network or deep learning models, we can clearly see that the similar word have factors which are similar to each other, that is the angle between them is smaller. So here you can see cat and houses are further away from each other, but puppy and dog are more similar in terms of their meaning, then they will be closer together in space. Similarly, man and woman, king and queen. So man and woman those have similar meaning, so they are closer together. King and queen has similar meaning, though they are closer together. Similarly, man and king has more closeness than man and queen. So as we represent the numbers, represent the words as numbers in space, what happens is that when the neural network is used to create the embeddings, the final resulting embeddings are formed in such a way that similar words are placed closer together in space. So why use word embeddings? So to represent high dimensional data efficiently, we use embedding. And embeddings enables us to do similarity search by measuring vector distances. Let's say we want to do some keyword search and we want to find some more similar word. So we can simply take the cosine similarity or Euclidean distance as a similarity measure and find the closest embedding vector to that word and reconvert them back into word form to find the similar word. And so it is the basis behind most of the AI applications currently being used. So any kind of AI application you use, they use embeddings behind the scene because we need to convert the words or images or all the other data into embeddings before feeding them into any kind of AI model. For example, a large language model or image recognition model for etc. So here is a video where we can see the embeddings being represented in space. So visual for visual understanding, this is a good example. So in 3D space, you can see similar words are being placed together and dissimilar words are being placed further away from each other. So in this way, we can represent text data in a numerical format which has a contextual meaning and embedded into it. So instead of directly representing the numbers, representing the data as numbers, we use embeddings because they also encode the contextual information or the meaning of the word into that numerical representation. So how are embeddings created? So generally embeddings are created using neural networks. So we preprocess raw data and text or images, and after that we convert it into numerical some numerical format like one hot encoding and other techniques are used to represent in a uh, numerical format, and then we feed those into neural networks like classical models like R2-Vec model or BART models or any LLM or any CNN based model we can train to give us the word embedding. So once the model starts running, its objective is to encode similar data points closely in vector space, and generally it gives us dense vector representing semantic meaning of the input. So we can refine our pre-trained embeddings for a specific task or specific domain also. So if you want to use it for text classification, we can fine tune the model to give us better results. So it's the simple way we create embeddings using neural network. So we pre-process the data and represent it using some numerical format, and those numerical numbers representing the words are fed into the neural network, and it once it's being trained, finally we get numerical representation of those data set in such a way that uh, it encodes the contextual information inside them. So these embeddings are very useful for different downstream tasks like text classification, summarization, named entity recognition, or any text generation task, etc. The role of embedding in RAG. So in RAG, we transform our queries and documents into vectors format. So after that, we pass them through embedding model, and it gives us the word embedding representation of those queries and documents. So once a query comes into the model, so it tries to find the most similar embeddings in the vector database to that query. And once those vectors are found using some similarity measure like cosine similarity and other measures, we use those embeddings to pass to the LLMs, and the LLM produces the answer based on that query, and we reconvert them back into text format. So it is the core foundation behind the RAG model. Thank you.